I honestly might need to run pretty soon here. So I might just head on out. Sorry, guys.
Okay, cool, no problem. See you later, Jay.
Bye.
So I was trying to make some schema about what do I think we can do with this additional processes and this communication. So I wanted to ask you: Is this make sense to you? How Arnold now is working, and how can be extended to this system processes?
So let's see here. I'm starting at the left. So we've got tuple space blockchain, Erlang, and Casper.
So if you are a user, you're calling via gRPC, you're talking to Casper, and he's on top of Erlang, and you can change the tuple space of blockchain.
Okay, yeah.
And also the other peers communicating with the same gRPC and doing the same thing, right? They're communicating with Casper, and this is the only way you can change the virtual machine.
Yeah, right.
Right. You don't have any other way to influence this, right? You must deploy and right.
Yeah. Yep.
And so the other thing inside the R node is almost the same as this one, but it's the tuple space that is not on the blockchain, right?
Yeah.
But it's almost the same. You're send something to Erlang, and you will change a tuple space. And I'm writing here more than one tuple space in case. It would be nice if you can just switch the tuple space and say, I'm executing this contract, but I will use this branch later. I will continue on this branch. And
that's a great idea. Yeah, totally.
So, and that's it. This is what can you do. You have this standard I/O to communicate, and also you have gRPC. Right. Okay. Yeah. What is eval? Eval is also gRPC, right?
Yeah, that's right. Yeah.
But also it's also standard I/O, because you are sending file and then through gRPC you're communicating. Okay.
Oh, yeah, that's right. Yeah. Well, yeah. What you send over gRPC is, dear node, please read this file, and then it does file I/O to get the actual code.
Yeah.
Yeah.
So, yeah, and I was thinking that this is like a big wall between these two Erlangs, these two virtual machines.
Yeah.
And from outside you can change the tuple space on blockchain.
Yeah.
But this Erlang here cannot do anything to ask this other Erlang, this other tuple space.
Yeah.
But for me, this is like strange, right?
Yeah.
Why this? They're so close, they're talking the same language. They're the same.
Yeah.
So if Erlang here can expose some API, maybe we can just deploy directly. And why go to the whole process of gRPC and then?
Yeah, I really love the idea of like linking those two worlds together. That's, I mean, I feel like that could start to get at a really solving a really painful point that I've experienced, which is like, there's some tuple space out there on the blockchain that we have consensus over, and I think I want to do blank transaction. I'd really like to run that locally. And then if it does what I expected it and intended it to do, then send it out to Casper and get consensus over it. I wonder if that could help here, where I do like a, test deploy in the middle column and then sync up with the blockchain that's in the left column.
Yeah, definitely. Yeah, one of this tuple space can be the exact copy of this one, for example.
Yeah, right.
And maybe you can split on one point and make your own progress for.
Oh wow! This is seeming a lot like I can git branch the public tuple space, make some mods, and then later merge those back into the public one or discard them or whatever.
Yeah.
That's a really cool idea. This almost seems like it might be a good way to start thinking about sharding.
Yeah, Chris B was pretty excited about this idea, which I guess we talked about in node testing on Thursday.
Oh, I'm so happy to hear that. That's great.
And he says he hasn't really thought about it that much yet, but it seems very interesting from the point of view of client-side Erlang code and potential sharding and all the stuff we're talking about here.
Oh, you mean sharding in a sense that you just split the tuple space and you have different shards, right? From one point.
Right. Where basically we have two of these Casper boxes, each one being a shard.
Yeah.
But having remote channels so that sometimes you're sending to a channel on another shard. So you have locality, which I think is an important aspect of decentralizing our chain.
So I see Casper as a library. This is how I see it.
Well, I'm just saying, obviously if you have a single user system, okay, like box 2 is essentially the client system. But if you have multiple shards, then there's a shard address associated with channels. So you're always sending to a local channel. So you're not having the case when everybody's sending to a different copy of the channel name globally. At least it's decentralized to the shard and to the individual.
I'm not sure that I completely follow you.
Tomislav, you've got the stack on the left side, right? Where one of those two, where you've got a tuple space that happens to have consensus over it. And you suggested this idea where maybe in the middle column, tuple space 0 is like your local branch of that same tuple space that's on the left, and you make your changes there and merge them back and forth as necessary. So if you like, but you must use deploys, because this is like a way to change the kind of stuff. Yeah, right. You still have to play the Casper game, right? You can't just like
yeah. Okay.
So imagine now, instead of just having a single fancy stack like the one on the left that includes Casper, imagine you have two of those, and like the other one, you happen to have your local fork that is synced up with tuple space 1.
You mean this whole thing?
Yeah, the whole stack with the tuple space, the Erlang, and the Casper.
But I imagine it more like this.
Okay.
Why do you need a copy of Erlang and Casper? You just copy the tuple space. I mean, the same Erlang and the same Casper will run.
I definitely agree the same Casper code and the same Casper game, but I'm not. Can it be that if it's the same Casper instance, then what makes it two tuple spaces instead of one?
Oh, I mean, not the same instance. Maybe it's not the same code. but this is just like a library, so maybe you will have multiple instances, but you know, it runs on top role of rolling, so you don't care.
Oh, I see.
I mean, in that sense.
Yeah. So you could have like two different sets of bonded validators on those two tuple space boxes at the top then.
Yeah, yeah.
Okay.
Like you have two databases. And
yeah, definitely two databases, but I'm asking, like, is it one consensus game that keeps track of the state of both of them, or is it two different consensus games?
I will say two different consensus games.
Yeah, yeah. Okay, cool, cool. So that, I mean, yeah, to me, that's starting to feel a lot like sharding. The question is, like, do they have some means of communicating and interacting with one another?
Well, I didn't think about that. Sorry, but yeah.
Well,
yeah, I didn't think about it.
What I'm suggesting is that if names are associated with the shard, and we always send, when we write to the channel, we always write to the shard where that is, that we won't eliminate the situation where every shard comes up with a different answer, and then getting global consensus is hard. Because there's in essence an owner of the channel.
I think we can say that we have this joint union on these channel names, and if we can say this kind of thing, we can just put all of these things together. But if we can differentiate between these two things, they can never conflict, right? You can never send on this other channel in this other set. So,
well, I mean, just take the simple counter example, where everybody takes counter value +1 and gets 1, and then they have to get a consensus on it. Okay, across shards. Okay, that's.
But I'm thinking that what is the purpose of shard if you want to use it in this way?
I want to decentralize our chain.
But Greg was explaining that, this is my understanding, that namespaces are like shards. So
yeah.
If you want to communicate between namespaces, you must create the third namespace and move this, what you want to communicate in this third namespace, and make a transaction there, and then return data back to your original namespaces.
Yeah, well,
this is how I understand.
I guess what I'm suggesting is that
I mean, you want to say that there should be some kind of synchrony between, if you want to communicate between shards. So I don't think that we need say which exact synchronization should be used. Maybe we can make up different mechanisms depending on the namespaces you want to use. Maybe if you have like a very frequent transactions with a very large amount of transactions, maybe you want to have this mechanism very, very simple and very fast.
Yeah, I guess the difference being every shard creates a namespace for all the names in the message and in the channel that's receiving it. They get a different and it's unsynchronized because
you're talking about specific implementation, right?
Yeah.
If you have specific,
I'm getting ahead of us here. I think I think that we do need to decentralize, and I'll work on maybe we don't need to consider it yet, but I think that can also be part of the sharding solution.
Hmm.
Go on, I'm sorry. Now, is this middle box,
Yeah.
is this middle box like a client? Is that how you're looking at that?
Yeah, this whole diagram is Arnold. Yeah, and what I wanted to say is that it would be useful to have this connection between this rolling that you use for evaluation and this one for blockchain. And also this right side is this extended processes that I showed you yesterday. For example, HTTP. So you don't need to have all of these things built inside the R node with all of these problems that this brings. Maybe you can just have these connectors that you can just enable for your R node, and in this part of the rolling, you can use it and just directly communicate with your external program. Is this make sense?
So instead of, so like if, so you're saying instead of like having directly inside of Rolang a way to do standard out, I'm not sure. I'm not totally sure.
I'm saying that maybe you don't want to have special endpoint outside of the Rolang for each protocol, for each technology. I'm saying that if you have this inside the Rolang, like a special name,
Yeah.
for example, maybe you can say something like new VS, and here will be row IO WebSocket. And here you can use it to, I don't know, to start the server, right? And here you can wait for the result when it started.
Oh, you have to configure the WebSocket somewhere.
Yeah, you're right. Maybe the first thing is configure. Read some data here.
Yeah.
And so you can. I'm thinking that all of this code can also be stored on the blockchain. So you can say, yeah, I offer you my web server directly in the Rolang, and the code for this web server is completely secure. It's on the blockchain.
So so hold the phone here. So you're saying like somehow in my local node, I can deploy code similar to what you've got here. It sets up a WebSocket endpoint on my node specifically, or whichever node I deployed it on. And now I have a name bound to it, WS. And now I can send that WS around as an unforgeable name, just like any other unforgeable name, and give it as an endpoint to someone else to use.
Yeah. And you can minimize what external code you need to use.
Okay, so yeah, so I'm thinking about that. That's an awesome That's a great thing to have for sure. So now I'm thinking about implementation. And I'm wondering, so like the unforgeable name security in our chain is interesting because they're totally secure in the tuple space, right? Like you can't steal access to them within the computational model. But when it represents some kind of underlying real world thing like a WebSocket endpoint, that seems like maybe the kind of thing that someone can just look into the blockchain and see like, oh, I see how that's set up. There must be an actual real world WebSocket endpoint listening there. Let me just go ahead and send requests to it.
Well, I was thinking about that, and I don't think that you can store this one on the blockchain.
Oh yeah, okay.
I was thinking that on the blockchain, you should not store anything else, than rolling without system processes. What is standard output in the blockchain? It's like a strange thing, right?
Yeah, totally. Yeah.
So I was thinking that maybe if you can listen on specific name inside the blockchain,
Yeah.
this is enough to just say, I'm waiting on this one, and I will start all these things when this name changed in the way that I'm expecting. For example, the transaction of revs are done, and I'm waiting on the result, and I will send some message back to my web application.
Oh. Yeah, I see. Okay, I think I'm starting to get it.
So although you cannot directly store it on the blockchain, you can have very close connection to the changes on the blockchain. So you can react immediately and just,
Yeah. Yeah, that's cool. That's great. So this is a cool design, right? What are you thinking about, like trying to build some of it or get our chain team to build some of it?
I want to post this on the Roland channel, but I wanted to first check if this sounds, if this makes sense and
yeah,
sounds reasonable.
Yeah, I mean the multiple tuple space I think is a little bit of a stretch. I mean the first step is just one tuple space. I guess if I'm understanding the operations in the center Rolang, are the things really communicating between the outside world and the blockchain, but they're not really on the blockchain. Is that correct?
Yeah. They're part of the evaluation tuple space.
So we can consider this middle thing to be off-chain. Right?
Yeah. As it right now. Yeah, we don't have a way to access all of these things that you can access from the standard I/O, like a show box. You cannot do this directly in Roland. So this is this block API that I was thinking about. Like, if you can search Roland, maybe you would have something like row block API or something like that. Then you can search something, right? You're searching inside the block. You're searching some code.
Like what kind of thing? Like the latest block height or something?
Yeah. Or you want to process some history or something.
Yeah.
Why not program this inside the Roland? Why
Yeah.
I'm thinking how to use rolling for everything. So
Yeah. Yeah. Right. I love that.
yeah, but I will try. So in the next step, I will try to make a web server directly in Rolling with this extension that I have. So, but but directly in Rolling, like the old-fashioned way. You make a post and Roland will give you HTML, and then you make a post and Roland will get you HTML.
Yeah.
Like very crude, but completely on like inside our node.
Yeah.
Now, if we had
Okay, with the help
Jason connect, we can put Roxy in the middle there.
Well, I mean, that is where I was going to go. Once you have eventually like all this nice stuff that you can do with Rolang, at some point it makes sense to say like, you can use Rolang without also downloading a full node for this blockchain that you might not really care about.
Yeah.
I mean, obviously I care about the blockchain a lot, but like if, I'm just a web server developer, I might not care about that.
Yeah. And maybe, you're running 10 of your R nodes on the blockchain, for example.
Yeah.
So maybe you want to store the whole blockchain on the 2 of your nodes, and you can say the other 8 will trust these 2 of my nodes, and they will not store the whole chain. They will just store the hashes of the latest finalized blocks, and
some kind of appropriate lightweight thing.
Yeah. So that's something that you can run on the phone without any problems, because you have your other full nodes.
Yeah, nice. I like that design. I'm super excited to see how it works out. Do you have any sense of how hard it might be to make our node keep track of multiple local tuple spaces instead of just the one?
Oh yeah, I look at this, and now you have multiple tuple spaces but they are all part of the same genesis, right? Because in the code you have checkpoints that you can execute some code, but when you're validating, you are executing this contract, but later you're just resetting the snapshot and you start again. So this functionality already exists for reversing changes. This is what I ask on the Archen testing. If this checkpoint can be exposed to the user, so you can say I make this I evaluate this code, but this code gives me back some transaction number, and I can later say, okay, reset to this transaction. In a sense, reset to this previous point.
Yeah, right. I got you. Yeah.
But to have multiple separated tuple spaces, I'm not sure how this. Yeah, I couldn't make direct call to almost anything from one rolling project, because you don't have a dependency to Casper and all the other stuff. So for me, the HTTP was like the easiest step. I just add one, not the best library for HTTP, and just put it in. And
yeah.
But I would like to have all of these dependencies from other projects.
Yeah. Cool.
Okay, thanks for listening.
Yeah, I'm excited to see how that comes along.
Me too.
Nice. All right. I don't have anything else to offer today. You guys want to call it a day?
Yep, I have another meeting coming up.
Nice. All right, cool. Good catching up, everybody. See you again soon.
Yeah.
Bye.
See you.
Bye.
Bye-bye.